Good morning. This is section 11.6. We are simplifying radical expressions involving addition and subtraction. Your homework tonight is page 505, 1 through 42 odd, and page 497, number 1 through 10 all. We have two sections we're covering. One's kind of a mini section. So today we're simplifying our radical expressions involving addition and subtraction. And the thing that you need to remember is a radical expression takes on the characteristics of a variable expression. So if it's a rad 7, it can only be added with another rad 7, meaning we can only add and subtract like radicals. We cannot add and subtract the not different radicals. And when we do that, we really are only adding and subtracting the coefficients. So when I have 3 rad 7 and 5 rad 7, how many rad 7 total do we have? We have 8 rad 7s. Here I have, it looks like I have 5 rad 3s, but I'm taking 1 rad 3 away. That means I have 4 rad 3s. Pause the recording and try the next few on your own. All right, let's check your work. I have 2 rad 5 and 1 rad 5. That makes 3 rad 5s minus 7 rad 5s. That makes negative 4 rad 5s. The next one we have 6 rad 2s minus 1 rad 2 minus 2 rad 2. So 6 rad 2 minus 3 rad 2 makes 3 rad. Whoa, look what Miss Yamasaki did. She made a mistake. Notice that these radicals are not the same. Wow, what was I thinking? Okay, so when I combine, I can only combine the like radicals. So here, I'm really going to look at 6 rad 2 minus 1 rad 2. That makes 5 rad 2s. And then we have minus 2 rad 6. Okay? And there's no perfect square left in there, so I can't break it down anymore. All right, let's try again. Let's try some more. All right, so a like radical versus an unlike radical. Like radicals can be combined where unlike radicals can't be combined. So 3 rad 7 and 2 rad 7 makes 5 rad 7. But if I have something like 8 rad 7 and 3 rad 5, they cannot be combined. That's like saying 8 x's and 3 y's. We can do 7 rad 11 minus 3 rad 11 is 4 rad 11, but we cannot do, this is a non-radical with a radical expression. Make sure you're looking at that's a non-radical with a radical expression. We can't subtract 6 minus 2 because 6 is not a like term. This is one term right here. Okay? 1 rad 10 plus 1 rad 10 makes 2 rad 10. But 1 rad 5 and 5 rad 2, again, the radicals are not the same, so we can't add them. Okay? This looks like they're different, but if I break down that 20 to its 4 times 5, which would be 2 rad 5, right? Now we actually have 2 like terms. So I have 2 rad 5 minus 1 rad 5, and that equals rad 5. That simplifies to 1 rad 5. Okay? So we can simplify our radicals. We don't know if they're like terms. Let's see if these are. Let's pull out our perfect squares. 32 is made up of 4 and 8, or 16 and 8, 16 and 2. And 18 is 9 and 2. So I have 4 rad 2 plus 3 rad 2. That makes 7 rad 2s, since they're like terms. So that's basically what we're going to do. We're going to break down our radicals, and then if they're like terms, we can add or subtract them. So I'll do one more with you. 12 breaks down to rad 4 times 3 minus, this breaks down to 9 times 3. So this becomes 2 rad 3 minus 3 rad 3. That makes negative rad 3. Okay? Now pause the recording and try the next couple on your own. I would like you to work vertical and put that answer beneath it, because these are expressions, not. So you're doing 2 through. All right, let's check our work. So now we've got, let's break this down to, I'm going to break this down to 30 because I'm thinking there's 9 and there's a 4. 9 times 8 in 72. And in the 8, there's a 4. So 9 times 4, that's 36 times 2. Minus, this is going to break down to 4 times 2. So this becomes 6 rad 2 minus 2 rad 2. That makes 4 rad 2. Okay. We'll take 75 and we will do 25 and 3. We can do 48 as 16 and 3. Remember, we're trying to break it down to the perfect squares. So it doesn't help to do 6 and 8 unless you break the 6 down to 2 and 3 and the 8 to 2 and 4, and then you can take out the 2's and a 4. So I have a 5 rad 3, and then we have a minus 4 rad 3 and another rad 3. And when we simplify that, that's 5 minus 4 is 1 plus 1, that's 2 rad 3. Okay. Let's look at the next one. I'm going to break it down. It's 9 and 10, 4 and 10, and 5 and 4. So we really have 3 rad 10 minus 2 rad 10 plus 2 rad 5. 3 rad 10 minus 2 rad 10, these are the only like terms. They simplify to rad 10 plus 2 rad 5. That's all we can do. We are as simplified as we can get. Sorry, I'm scooting around. All right, let's add some variables to the mix. So in this case, I'm going to, I can break that down to 25 times 2 times y squared minus square root of 4 times 2 times y squared. I can pull out a 5. I can pull out a y. I have under the radical a 2. And here I can pull out a 2 and I can pull out a y, and under the radical we have a 2. So 5y minus 2y. Okay, now this is getting a little sneaky. 5y minus 2y is 3y, and they only can we add them if it's the same radical too. Remember, we don't add that radical underneath. Okay, try the next 3 on your own. Okay, let's check our work. So we can break down the 12 to 4 times 3x to the 4th, 9 times 3x to the 4th. So I can pull out a 2 and an x squared, and I can pull out a 3 and an x squared. And so I'm left with a rad 3, and then a 3 and an x squared, and I'm left with another rad 3. Now, we have to have both kinds of like terms, meaning 2x squared plus 3x squared, we can add them. That's 5x squared, and then it's all times rad 3. So on the next one, can't break this down anymore. This is 1 rad 5x, and I'm going to do 25 times 5, and we're going to have an x squared and an x, so that becomes 5. I can pull out a 5 and I can pull out an x, and then what's left is 5x. So I have 1 times rad 5x plus. Okay, now in this case, no, what you have to notice is that 1 and 5x, we can't add them together. So we have to put in parentheses 1 plus 5x. That whole thing is going to be multiplied by 5x. It's the reverse of the distributing property, right? Okay, we'll one more time, I'm going to show you that. So we can break down our to a 5x and a 5x times rad 5x. Since 5x and the coefficient 1 aren't like terms, this coefficient right here, I just lost my Apple pen. Since this is not a like term, the 5 and the 5x, we're just going to have to write it as 1 plus 5x in parentheses times the quantity of rad 5x. All right, try the next one if you haven't done it. Now check. I can take out a 4, and I can take out an n squared. And here, I have to break it down to 4 times 5 times n squared. So I can take out a 2 and an n, and what I'm left with is the 5. Right? So I have 4n squared. Now in this case, because it's not multiplied also by a rad 5, I just leave it. I leave it just like this without the parentheses. No parentheses. Okay? So the difference here is the one on top both had a rad 5x. That's why I needed the parentheses. This one, there's no rad 5. There's only one rad 5. So I'm not multiplying the rad 5 times everything. Okay, it's a pretty quick lesson. Okay, here we go. So now we're doing, we have to simplify our binomials. And I'm going to take out a 9. And I'm left with, under the radical, x squared plus 1. And I can factor out an x squared. And then when I do that, I'm left with another x squared plus 1. Okay? So. All right, so I can take a root there. It's a 3. And I'm still left with my x squared plus 1. It can't be simplified. And I can take out an x squared here. And so then we end up having 3 plus x, no parentheses. Oh no, we do need the parentheses. 3 plus x in parentheses because they're both times the square root of x squared plus 1. So I do need those outside parentheses. All right, next one. Pause it and try it on your own. Okay, let's check our work. Okay, we're going to break it down to 9a squared times a minus 2. I'm going to break this down to 4, and then I'm left with an a minus 2. We can pull out a 3a out of the first one, and a 2 out of the second one. 3a, and I'm left with rad a minus 2. I can pull out a 2. And so we are left with, we have to now combine our like terms as best we can. 3a and 2 don't mix, so we're just going to list it as the quantity of 3a plus 2 times rad a minus 2. Okay? All right, this is, okay, we've got fractions. So in order to add fractions with radicals, we have a couple different things we have to do. We have to get rid of the radicals in the denominator, and we also have to have a common denominator in order to do this. So I'm going to start with a common denominator. I'm going to break it up into 4 different. This is over a 1. And over here, you can do it a couple different ways. I was going to say I'll just multiply by rad 5 over rad 5. Right? Well, they're going to rationalize first. So if I multiply by rad 5 over rad 5 on the right, then what I'm going to get is a rad 5 over 5. Let's rationalize first, because then when I try and figure out the other side, in order to get rid of the rad 5, I had to multiply by a fancy 1, because rad 5 times rad 5 is 25. I pull out a 5. Now over here, all I have to do is multiply by 5 over 5, and we end up with 5 rad 5 over 5 minus 1 rad 5 over 5, and that simplifies to 4 rad 5 over 5. Okay, so first I got rid of the radical on the first one. I got rid of the radical by multiplying by this fancy 1. Then I had to find the common denominator and use my identity property here. And now we have like terms. Oops, I don't know what I made a boo-boo here. This has a 5. And now we have like terms on the denominator, so we can add our numerators. Let's try the next one. You can pause it if you want to try it on your own. Separate them all. Okay. Now, I'm going to multiply it by so they can both, let's see. Let's try multiplying by, I can multiply by rad 3 over rad 3 just to get rid of the radical. And the next one I'm going to multiply by will be rad 6 over rad 6. Right? I'm rationalizing first. And then I'm going to multiply that first fraction. It needs to have a common denominator by 2 over 2. So now I get 2 rad 6 over 6 plus 1 rad 6 over 6. And that simplifies to 3 rad 6 over 6. Now my non-radicals can be reduced to 1 over 2, so the solution is rad 6 over 2. I cannot cross-cancel the 6 and the 2 because the 6 is in a radical, the 2 is not. Okay? I think that is it for there, but we have another section. I'm going to pause it. Hold on. I've just got one more thing to show you. Okay, I think I'm going to put this in a second recording, so it's pretty easy to do. So I'm going to stop the recording now, and I'll attach both recordings.